Alright, let's take a look at SPM year 2019, paper 2, questions number 9. So, solutions by skill drawing is not accepted. Diagram 5 shows the path of a moving point P, X, Y. P always move at a constant distance from point A. So that means P moving in a circle and A is the center of the circle. So B, we have -1 and -2, and R, -5 and Q lies on the path of point P. So the straight line BC is the tangent to the path and intersect at the x-axis at point C. Right? Find the equation of the path of point P and the possible values of Q and the area of triangle A, B, and C. So part A you have 3 marks, part B you have 2 marks, and part C you have 5 marks. So total you have 10 marks for these questions 9. Right, first part, we are asked to find the path of point P. Okay, A and P always maintain constant distance. So that means it is a circle and the constant distance is equals to R, the radius of the circle. So we know that point B and point R lies on the path of P. So can we find the equations of point P, the path of point P? Right? We can use the distance between 2 point equations to find the equation of the path of point P. Alright? So we know the center is -2 and 1, and a point B, it is -1 and -2. So we can use this to find the radius. That means the distance between the center and the point on the path. So this will be, let's say I will use point B. Okay, point B minus point A. The distance between point B and point A will be okay, let's use the x first. -1 minus -2. The whole thing bracket square plus y. Y will be -2 minus 1 square. Then the whole thing square root. Right? So this is the equations. This is the distance between 2 points. And then another point we are using A and P, because P is a moving point. We definitely need the xy. Alright? So this will be x minus -2 and the whole thing bracket square plus the y. Y will be y minus 1 square root. Right? Do you notice that on the left hand side of the equation is the equations between 2 points, and the right hand side of the equation will be distance between 2 points as well. So how do we remove the square root? Okay, by squaring both sides. Right? When we square both sides, what do we get? -1 minus -2 is 1 plus -1 plus 2, I get 1. 1 square, I get 1. Plus -2, -1. Okay, -2 minus 1, I get -3. -3 square, I get 9. Equals to x minus -2. That means x plus 2 bracket square. So x plus 2 bracket square, I will get x square plus 4x plus 4. And plus y minus 1 bracket square, I will get y square minus 2y plus 1. Right? Then we rearrange everything into one side. So x square plus y square plus 4x minus 2y. Okay. And then 4 plus 1, I get 5. 5 minus the 1 and 5 minus 10. I'll get -5. Right? So this will be the equations of the path of point P. Second part. Find the possible value of Q. Alright, so Q lies on the path of P as well. So that means we can substitute this -5 into the x and Q into the y, into these equations. This one. Right? So at point R, negative 5 and Q, which is, so we substitute into it and we'll get x squared will be negative 5 squared plus Q squared plus 4 multiply negative 5 minus 2Q minus 5 equals to 0. Right, and then we have Q squared minus 2Q, negative 5 squared, I get 25. 25, I minus 20, I get 5. 5 minus 5, I get 0. So what do I get is Q squared minus 2Q equals to 0. And then we factor out the Q, I will get Q minus 2 equals to 0. So our possible solution will be Q equals to 0 or Q equals to 2. Right? And then find the area of A, B, C. Okay, we know the coordinate of point A, we know the coordinate of point B. So what is C? What is the coordinate of C? So we know that the straight line BC is the tangent to the path So that means the straight line BC is the tangent. So we need to differentiate the equations of the circle so that we get the gradient of tangent. Okay? And then we substitute point B into the gradient of tangent. And then we have the gradient. With point B and with the gradient, we can find the equation of the straight line. And we know that the BC line is intersecting at x-axis. So that means when we have the equation of the straight line BC, we substitute y equals to 0 because on x-axis. Then we can find the point C. When we have the point C, we have point B, we have point A, then we can find the area of the triangle ABC. Alright, so let's find out the gradient of tangent. So gradient of tangent will be, we differentiate the equations of the circle, which is x squared, which is this one, the one I underline in yellow color. Right, when we differentiate this one, what do I get? Differentiate x squared, I will get 2x. Okay, differentiate y squared, I will get 2y dy dx. Differentiate 4x, I'll get 4. Differentiate negative 2y, I get negative 2 dy dx. And then minus 5, I get 0. So equal to 0. Alright, so let's rearrange it to make the dy dx as the subject. That means dy dx is equal to equations. Alright. So we leave 2y dy dx minus 2 dy dx equals to negative 2x minus 4. And then we factor the dy dx out. I will get dy dx is equal to 2y minus 2 equals to minus 2x minus 4. Right, and then we move 2y minus 2 to the right hand side. And then what do we get? Dy dx is equals to minus 2x minus 4 over 2y minus 2. Right? So this is the gradient of the tangent for the circle, okay, for the path of point P. So now we can substitute the coordinate of B into this dy dx. That means the gradient at point B, gradient of tangent at point B, right? So at point B, B is negative 1 and negative 2. So my dy dx is equal to what? Minus 2, x will be minus 1, minus 4 over 2 minus 2, minus 2. What do I get? Minus 2, minus 1, I get 2. So 2 minus 4, I get minus 2. Minus 2 multiply negative 2, I get negative 4. Negative 4 minus 2, negative 6. So that is 1 over 3. The gradient is 1 over 3. Alright, so let's find out the equations of BC. So the equation of line BC is equal to what? So we know the point B, okay, the coordinate of point B. So that is y minus 2 over x minus 1 is equal to the gradient, which is 1 over 3. So we cross multiply, we'll get 3y plus 6 equals to x plus 1. Okay, then we rearrange it and we will get 3y minus x plus 5 equals to 0. So this is the equations of straight line BC. And then we can use this to find the point C. Because we know that point C intersect at the x-axis at point C. Alright? So at x-axis, y equals to 0. Right? Then what can I do is I substitute 0 into the straight line equation. This is the straight line equations. Substitute into it, then I will find the coordinate of x. Okay, so 3 multiply 0 minus x plus 5 equals to 0. So x equals to 5. Therefore, the coordinate of point C is 5, 0. Right? So now that we know the coordinate of point B, point A, point C, so can we find the area of triangle A, B, and C, triangle ABC? Alright, so the area of triangle ABC. Okay, do you still remember how do we find the area of triangle ABC, area of a triangle in your coordinate geometry chapters? We have 3 coordinate. Using that 3 coordinate, we can find the area of the triangle. So the area, which is A equals to half. Okay, let's use point A first. Negative 2 and 1. And then we use point B. Negative 1, negative 2. And then point C will be 5, 0. And then don't forget to repeat your first point, which is your point A. Negative 2 and 1. Right? So 1 over 2. Okay. So how do we do this? The yellow color one, we multiply together and then we add all those 3 yellow color together. And then we minus out the red color one. Isn't it? So let's do together. So 2 minus 2 multiply minus 2. I get 4. 4 plus negative 1 multiply 0. I get 0. 5 multiply 1. I get 5. Minus 1 multiply negative 1. I get negative 1. Minus 2 multiply 5. I get minus 10. 0 multiply negative 2. I get 0. So we 1 over 2 multiply 9 minus negative 1, negative 10, I get negative 11. 9 minus 11 is 20. So 20 divided by 2, I get 10. So the area will be 10 units square. Alright, so that's all for now. I'll see you next time.